So our next speaker is Andranik Khachatryan. He's a consultant at Toptal, and he's going to talk about the machine learning in cloud. So I'll ask Andranik to share his screen and start.
Can you see my screen? And
yes, we do.
Hear me?
Yeah.
Okay. Thank you, Arsen. And today I will be talking about production-grade machine learning in the cloud. So a typical machine learning or data science project involves many steps. Typically, it involves building, training, and deploying and monitoring a model. Usually, there are different specialists with different kind of skill sets involved in this process. For instance, people who do deployment and monitoring are not necessarily data scientists. This creates difficulties and frictions in the whole process. One of the things is that usually at the first iteration where the model is created and deployed in a production, the team doesn't think about all the features that they need to add. For instance, what will happen when suddenly we have an increase in requests to our model? How are we going to scale the model? So these kind of things are typically left to whenever this happens, and this can this can result in a situation where later on, when you need to add these features, the system is not engineered well enough. So Amazon SageMaker is a AWS offering of platform service for machine learning, and it addresses these issues. So the goal is to enable data scientists and machine learning specialists to cover the whole process. So as a data scientist, for you, deploying and monitoring the model into production becomes as easy as training it in your Jupyter notebook. Okay, so a bird's eye view on machine learning services from AWS, and this picture has sort of a hierarchical structure, which I think is inherent in other cloud providers as well. So at the top, we have application services, which are API level services, which do a sort of a limited task. They do it pretty well. For instance, Amazon Recognition is an image processing service. You give it an image and it will do object detection, face recognition, labeling, and several other things. You have limited ways to customize it, but it is very easy to use. So it's just an API call and you get, it's infinitely scalable and it's pretty cheap. So at the bottom, there are is the compute layer, where essentially you rent a machine, you install things on it, and you SSH on it, and then you do remote development or training on this machine. So at this level, you have complete control over everything. So platform services sit in the middle, and the idea is to be almost as easy to use as the application layer, while being almost as flexible as the compute layer. Okay. So what SageMaker does is it manages your resources for training and deployment. So it's a managed cluster. For instance, it does load balancing, auto scaling. It contains large number of algorithm implementations. So for instance, XGBoost, K-means, and many others, as well as deep learning algorithms. And it also allows you to write your own code, and it will execute it inside inside a container, let's say a PyTorch container. Another nice thing is that it's modular, so you don't have to use it for the whole cycle. For instance, you can train your XGBoost model on your laptop or on your server, wherever you like, and you can use SageMaker only for deployment. So if you like your workflow of training on your machine and you don't want to use their stuff, you can do it and use it only for the deployment and monitoring. Okay, so here is a sort of a picture of what happens when we use the existing algorithms, existing containers in SageMaker. We say what kind of algorithm we want, let's say XGBoost. We say what kind of machine we want to train. That's the that's M4 in here. We specify the training data, which sits in Amazon S3. And SageMaker will take care of provisioning an instance, putting the container, and then train the model, put the model artifacts on S3. We then, at inference time, when we want to create the endpoint, we specify the inference container, what kind of machine we want this endpoint to be deployed, and it will again provision the resources, put the trained model file into this new machine, and wrap this all around a REST endpoint. And at that point, you have a working REST API deployed, which is serving your model. Okay, so if you are connecting to this from within AWS, then this is as easy as essentially providing the address of this service endpoint, and then you're good to go. You can send predictions, and from outside, typically you need to also you put a Lambda and an API gateway, but often this is also a matter of minutes to get this done. Okay, so in a slightly more complicated scenario, let's say when you're doing, when you're training a custom PyTorch model for deep learning, so you have a bunch of code and you have lots of packages that you want to install. So then you specify what kind of framework you want to use. In this case, PyTorch. You say where your code is, and what will happen is SageMaker will create the instance that you need, download the training data to your instance, put your code, install all the packages you need, and then run your code with the command line arguments that you provide. During training, it will save you checkpoints, emit TensorBoard data, and so on and so on. So you don't even have to wait, let's say, till your training finishes. If you want to, if you have a long-running process and you want to see your loss metrics during training, it will emit this into emit this TensorBoard data into S3, and you can access it while the training is running. This is important because the cluster is managed, so you cannot directly SSH to the machine that's running this code. So this is inside behind essentially the cluster. So at inference time, again, so you have your code, you specify where the model is, it will put the code, put your model, wrap this around a REST endpoint. You will get automatically auto-scaling model variants, so you can do A/B testing, hot swap on configuration change. I will briefly tell about this next. Integration with other services such as AWS CloudWatch, which is logging service, and others. So let's say if you want to see what's the let's say CPU and memory load on this endpoint, how many times your endpoint has been invoked, all this kind of logging information is automatically gathered and in dashboards and in other formats for you in CloudWatch. All of this, of course, is doable. I mean, you can do it yourself if you do a web service based deployment, but this is lots of heavy lifting which you actually don't want to do. So it's not something that is your main job as a data scientist. As a data scientist, you want to model, focus on your models, on their performance, and so on. Okay, so to demonstrate how easy some of the things are, so let's say we want to update our endpoint. So we have a running a REST endpoint, and we want to update it. We have trained a new version of our model, and we also want to update the machine that this model runs on. Okay, so what we do is we create a new configuration file, which is essentially a JSON file, which says that the new model, which points to the new model location on S3, which has the new machine as a string, and we update the endpoint with this new configuration. So SageMaker will create this instance, essentially put everything into place, get this running. It will deploy it, and then it will change our endpoint to this new one. And then it will delete the old one so that you don't have to pay for the old machine. And while this is getting done, your endpoint is accessible. So all this time you can send predictions, and up to some point in time it will be serving the old model, and from some point on it will be serving the new model. Again, this is nothing groundbreaking in terms of, I mean, this technology exists, but typically you'd have to do some amount of manual job to get this done, and in this case SageMaker gives you a single API call for update endpoint. Okay, so another thing which is I think really important is the inference pipelines, which is a feature allowing you to stack several models. So typically in a production scenario, we have data. For instance, we have data which has lots of strings in it, and we want to do pre-processing. We want to clean the data, and then we want to one-hot encode it. So once we do it and then we train the model, what we would really like to do is to make sure that the same code that runs the processing at training time, the same code runs also in the inference time. So when at production, when a user sends a row into our model, it goes to exactly same code does the pre-processing. Okay, so in scikit-learn, this is implemented by model pipelines, where you can have you can stack models. So the output of the first model goes into the second one. SageMaker also supports this kind of thing, where you can have several containers and you can stack them so that you can have pre-processing, then you have your actual inference, let's say doing XGBoost, and then you can also have a post-processing, which is not pictured here. So this allows for this allows you to run the same code for inference and training with regards to pre-processing, and it makes sure that you don't have some very hard to diagnose problems where the code, where some change in the code base results that your training and inference preprocessors are executing differently. And this is very hard to diagnose. Okay, so some other nice features. I mentioned production variant. So this is something that allows you to put a new model under the same REST endpoint and redirect some percentage of traffic into this new model. Okay, so this is great for A/B testing. When you have a working model and you have a new one, you have tested it on your testing environment, but you also want to test it in production. Again, you can do this with other means, but with SageMaker, this is really easy. You put 2 or more models under the single endpoint, and then you specify how much of the traffic you want to go to each of them. The other one is automatic hyperparameter tuning. So SageMaker allows you to do random hyperparameter search, but it also has some pretty complicated Bayesian optimization based hyperparameter tuning. In my experience, this works at least slightly better than the random search. And there is auto scaling, which allows you to scale your models when you get a traffic increase. So you have a model deployed on a machine, and then suddenly you are getting 5 times more requests. Then SageMaker will automatically provision more instances, deploy your model, and put a load balancer in front of it, so that on your side and on the user side, nothing is happening. They're still accessing the same REST endpoint, getting the replies, but under the hood, now there are more machines serving the model. Okay, so I wanted to show also, can you see the notebook? Is it?
Yeah.
Okay, thanks. Okay, so this is a really toy example. I just wanted to show. Yeah, so on the left side, these are example notebooks from AWS, and I encourage particularly starting data scientists to have a look. These not only demonstrate the AWS functionality, but there is like large number of interesting, actually, sort of pure data science, interesting stuff from pure data science point of view. Okay, so there is some data processing going on. Not really interested. I just wanted to show. So we are getting the container, which is essentially the Docker container, which contains the algorithm. And in this case, we want a linear learner, which is a very buffed up version of linear regression and logistic regression, sort of advanced version of that. So we create an estimator using that container. We tell which kind of machine we want to use, and we say, please save your output in this location. Then we set some hyperparameters, and then we tell SageMaker, yeah, go fit. And so what will happen? It will start a training job, launch the instances, download our input data, the training image, and then what comes next is already the output of the training container. So this is the Docker emitting these strings. Okay, so we the training is finished, we look at the numbers, let's say we're satisfied, and then we want to deploy it into production. And this is how you create a web service deployed in the cloud. You say what's the kind of machine you want, and then now this is essentially a wrapper around that web service. And now we can start sending data into this web service, and then get our prediction. Okay, I'm done, I think, and open to questions.
Thank you, Andranik. I see there is already one question in the chat, so well, I can read it. And the question from Vahe Hakopian is the following. How hard is it to build a custom solution, aka build own Docker container and deploy it on SageMaker?
Yeah, thanks, Vahe. So I've never done this myself, frankly, but SageMaker, so essentially it has three levels of how you can deploy. One is the container level, which I showed. So this is when you use the ECR container, like in this example. The next one is the framework level, where you have a bunch of code in PyTorch and you are using the PyTorch sort of environment, but you are writing already all of your code. And the third level is when you provide a Docker container. So I haven't tried this because I'm not actually a Docker expert. So this is something which, again, this goes beyond the typical data science scenario. So I would have to go to someone who does Docker operations people and haven't needed it in production. But so you can do it, and there are people who are doing it. I haven't done it myself, so cannot tell how hard it is, but this is a supported scenario.
Okay, Andranik, thank you for the answer. I see the questions are coming in the chat. So the next question by Dennis Volk is the following. Pricing. I guess pricing and then a question mark is one separate question. Will you, Andranik, prefer to read the questions themselves and go through the answers? It will be much faster, I think.
Yeah, okay. So pricing is hyperparameter. So this is from Dennis Volk. Pricing is hyperparameter tuning possible for custom models, non-standard sklearn or XGBoost. How vendor locked I get with SageMaker? Is it easy to take a pipeline from SageMaker and use somewhere outside of AWS? I trained the linear learner on SageMaker. It's some container I have no access to, right? Can I get the raw code for inference and retraining? And then there is a question from Karen, does SageMaker support training on spot instances and auto recover? So these are somewhat related. So Karen's question, yes, actually I have been using it. It's great, and it drastically reduces your training costs. So for those who don't know, spot containers, spot instances are spare capacity from AWS. So you get the same machine for much lower price, but they can stop at any point in time. Okay, so when someone really needs it, they pay the full price and they take the machine for you. So the scenario where you run this is you also put in some code so that you can recover from a checkpoint. Okay, so this works, is much cheaper, and it works really easy because you only need to manage your checkpoint thing, which again is simplified. You don't need to do any other changes except providing a Boolean parameter saying that you want to use the spot instances. So this regards to pricing, Dennis, I think so. The pricing is essentially you are paying standard EC2 price plus a premium because this is inside. So this is essentially you're also paying the SageMaker premium, right? So you're not only using the machine, but you're also using the SageMaker, but you can use the spot instances. For instance, hyperparameter tuning, spot instances is a really great way to do hyperparameter tuning, because you run, let's say, 100 sweeps, and then you really can do this with spot instances. Can you do it with non-standard things like sklearn and XGBoost? Yes, you can. There are some restrictions, and you have to so there is no like simple generic answer of what you can and what you cannot do. But yes, you can use some custom losses and so on and so on. And for instance, you can use it for your PyTorch model, which, as I mentioned, it works on a code level. So you can have your own code, and then the starting entry point of your code is essentially console application, and you can inject you can allow SageMaker to inject hyperparameter values through this command line interface that you're implementing. So how locked are you? Okay, in some cases, so for instance, with linear learner is a SageMaker. So this is Amazon algorithm. So as I said, this is not doesn't map one-to-one to scikit-learn, but with other algorithms. So for instance, with XGBoost, what you get is a wrapper around XGBoost, and underneath you get an exact XGBoost framework model. So it's a zip file. You can download it, you can extract it, you can put it into your notebook. The file you have, the model, the XGBoost model that you have trained with SageMaker, and inside it is a genuine XGBoost model which you can, let's say, diagnose using your notebook. So it depends on the kind of algorithm. With many algorithms, they use the standard open source implementations and sort of do the wrapper around it, and they have some in-house implementations which I think are harder to use, but they also have lots of stuff is open source, including the containers. So you'd have to have a look at specifically what you want to use and whether you can, whether it is one of those which is essentially compatible, or you can try to get it working using the open containers. Hope this answers the questions.
Thanks, Andranik. And again, you can ask questions to Andranik in the Slack channel whenever you want.